is the small components on the hardware. First, this is the resistor, the smallest small component on the motherboard. Not only for MacBook, I think for other phones or other laptop motherboard, resistor is the smallest components. Okay, most of the resistors on the motherboard are chip resistor. Start with R. And the function of the resistor is to limit the current. Okay. And the resistor unit is mega ohm, kilo ohm, or ohm. And here we can see some resistors. Here you can see it's very small. It's in black color. Okay, like this. Here, we will introduce some special resistors. First is the pull-up resistor. Pull-up resistor is to add a voltage on some special rails, the signal rails. We add a voltage. Here you can see PP3, V3. Voltage value is 3.3 volts on these signal rails. If there's no 3.3 volts, the signal cannot be transferred normally. Okay. And when it's broken, we have to replace them with the same value resistors. Okay. Second one is pull down resistor. The function is opposite of the pull up resistor. If we don't use the pull down resistor, the voltage on this rail may be higher. But if we use a pull-down resistor, the voltage value on this rail will be lower than before. Okay, that's the pull-down resistor. And also, when it's broken, we have to replace with the same value resistor. Okay, let's see the third one. The third one is the fuse resistor. Function for fuse resistor is for protection. When the big current is coming, the fuse resistor will be opened, and then the current cannot be flowed away to the other chips or components. So the fuse resistor will protect the circuits afterwards. And when it's broken, we can jump wire and replace with another one. The value is 0. Okay. But if you jump a wire, the fuse function will be lost. So the best way is to replace with another one. NTC resistor, negative temperature coefficient. And here you can see those are NTC resistors. So when the temperature is rising, the resistance of the resistor will be getting lower. Okay, that's opposite with the value of the temperature. When it's broken, we have to replace it with the same value resistor. Okay, so let's move on. Okay, here we have another special resistor. This type of resistor is current sensing resistor. It's like this. You can see a small component. It has 4 paths. Okay, 4 paths like here in the schematic. And it works together with 2 other resistors used for sampling the current. Okay, normally the resistance will be very low, like here, just 0.02 ohm. And those 2 resistors always also very low, like here 10 ohms, 10 ohms. Okay, current sensing resistor. Because they are used for current sensing, so sometimes if the current is very high, so it will damage this type of resistor. So the damage risk will be higher than other normal resistors. Also those 2. Okay. How to check a resistor? We use a multimeter and turn it to ohm mode. Okay. Ohm mode is the resistance mode, and one probe connected with the one side, the other probe connected with the other side, and then we will get the value. Normal value, the tolerance should be from 5% to 10%. Okay, so that's the resistor. When you check a resistor, it's better to take it off from the motherboard and check the value. Okay, so that's the resistor. Okay, let's see the capacitors. Different from the capacitors on the phones. The capacitors on the laptop, they are special types. This one with direction. You can see here, this is the positive side and this is the negative side. When you replace this type of capacitors, you have to take more care about the direction. Okay? And this type of capacitors is similar as the phones. Okay. So the function of the capacitors are used for filtering, energy storage, and coupling. It's short for C. Symbol is like this. And the capacitor unit is farad, millifarad, microfarad, nanofarad, picofarad. Okay. Let's see on the marble. Here we can see those big capacitors with direction. So when you replace them, you have to put them like this direction. Okay, and those smaller one here. Most of the smaller capacitors are used for filtering. Okay, those one, all of them are capacitors. Let's move on. Okay, here, filtering capacitors. You can see here. Normally, the value for the filtering capacitors is very low. You can see it's only 100 picofarad, 56 picofarad. Okay, you can see one side is connected with the ground, the other side is connected with the circuit. Okay, see the energy storage capacitors. Normally, energy storage capacitors used for the boosting circuit. This type of capacitor is like a small battery. It's charge and discharge, charge and discharge. Okay, so one side is connected with the ground, the other side connected with the circuit. But normally the value is higher. Okay, you can see it's 10 microfarad. Okay. Last type is the coupling capacitors. Coupling capacitors, you can see, is in the circuit. Those two types of capacitors are one side connected with the ground and the other side is connected with the circuit. For coupling capacitors, both of the sides are in the circuit. So as we know, the capacitor flow with DC power and AC can pass through. So for these types of capacitors, it allows the analog signal to pass through. Okay, alternate current can pass through. Okay. But the capacitors are broken, so we have to replace with the same value capacitor. Okay, let's move on. Okay, how to check a capacitor? We can use a multimeter. We choose the diode mode here and check the diode value. The normal value should be OL. If you check in the independent capacitor, and if you check on the motherboard, the diode value will be different. Okay, so if the diode value is OL, that means the capacitor is good. But if you check on the motherboard, it will give you some values. That's difference. Okay. Most of the short issues are caused by the capacitors because most of the capacitors are connected with the ground. So if the capacitor is broken, the electricity will directly go to ground, and the temperature will be very high, so it's very hot. So we can use the thermal camera to locate the short capacitor. Okay, more. Okay, let's continue to introduce the inductor. As you can see, those big
components are the inductors. Okay, they are used for energy storage. Okay, this is the symbol. Actually, inside the inductor, there are some coils. Okay, so it allows the DC pass through, but AC cannot pass through. It will block the AC. Normally, L is for the big size inductor, FL for the small size for the filtering inductors. Okay, the inductor unit Henry, millihenry, microhenry, nanohenry. You can see on the motherboard, those are small inductors, and this bigger one for energy storage. This one also. Okay, let's see another very important component, fuse. Fuse is an electrical safety component that is used for providing overcurrent protection. So the dangers should be higher. Okay, so you can see on the motherboard the small white component. Okay, normally it's on the outside of the circuit. And actually, we can say it's a special kind of inductor. It's just one special coil. Okay. A normal inductor, there should be many cycles of coils. Okay. So let's continue.
How to check an inductor? Here we also use multimeter and we use the diode mode. Normal value should be 0, as we learned before. Actually, inside the inductor is the coil, so normal value should be 0. Okay, so we can check the inductor on both sides. Of course, we can change the direction of the probe. This kind of inductor are not direction component. Okay. If the inductor is broken, most of the time the diode value will be indicated. The multimeter will show OL or 1. Okay, that's all for this lesson. We learned the resistor, capacitor, and inductor. In the next lesson, we will learn some other small components on the metal. Okay, see you in the next lesson. Have a nice day. Bye-bye.